right, for room right before lunch. Are you really this interested in CI/CD? Okay, so I want to talk about today the eternal struggle between platform engineers and developers. And before I offend everyone in the room, just show of hands who identifies as a developer, software engineer here? One, two, really? Everyone else, you must be platform engineers then. And? DevOps, yeah, that's kind of falls into the platform engineering category for me here. All right, so, and within that struggle, I'm going to focus on CI/CD because that's kind of the primary battleground between developers and platform engineers. And I'm going to use an imaginary example project to talk a little bit about the struggles with CI/CD today and kind of give you a few examples later on how you can solve some of those issues. And in the beginning, like even if you don't have a platform engineering team, even if you are just a startup with 3 developers, you have some sort of CI/CD, right? And it's usually, it may be something simple like this, like you want to build your software on some tests and linters, but very easily it can get out of hand and become something like this, like some monstrosity of YAML and bash scripts and maybe even some Python that nobody really wants to touch, like not the developers, not the platform engineers. Everyone just tries to avoid that whole thing, but sometimes you do need to change that. And that's when this happens. Like you make some small change, you push it to your VCS, and then you pray to the CI/CD gods that it doesn't break. But it always breaks, right? For the first time at least, or maybe for the second as well. And it's like a law of nature or something that it always breaks for the first time. And it can take anywhere between, I don't know, 5 to 30 minutes for these pipelines to run. And then you need to figure out what went wrong. And it's not always easy. Like you have to go through the logs, try to figure out what went wrong, try to fix it, push it again, and wait another 30 minutes to see if it breaks again or not. And it's just so frustrating, not just for platform engineers when they change the pipeline code, but even for developers when their code change breaks the pipeline. So let's take a little bit of step back from CI/CD for a moment. Every project needs a developer environment, right? You need some tools to install on your developer machine to work on that software project. Whether you use Brew or Nix or download Go from golang.org, doesn't really matter. You have a developer guide that details all those steps. But developers have a fairly lot of freedom to whatever they want on their developer machines. And then you also have like a developer interface that you interact with, like a makefile with targets that allows you to run common tasks like building your software, running some tests, and running some linters. And then on the other side, on the platform engineering side, you have a CI environment that does the exact same thing, but those two are in complete isolation. They are often in complete isolation. You have to install Go somehow. You have to run some builds, run some tests, maybe run some linters, and you often have like version spin to make sure that silent upgrades don't break the pipeline. But do you know what version the developers use? I don't know. I have this version in my CI config. Do you know what the developers use? So you often have, due to this complete isolation between these two environments, you often have drift between them. And then that usually leads to pipelines breaking, and that leads to frustration between developers and platform engineers. And the reason for that is that these environments are fairly dynamic, right? Like you often need to make changes. You may want to upgrade Go to use a new language feature, or you want to upgrade Go in the CI environment because there is a vulnerability in an older version. So on the platform side, you may have to make an upgrade, or introduce a new security scanner because there is a new company policy for checking vulnerabilities. But the problem is that these environments are completely separate, right? Like the developer environment is controlled by developers, CI is controlled by the platform engineers, and when you make a change on one side, you have to make a change on the other side. And sometimes it's easy, like sometimes you can just change something in your GitHub Actions YAML. Sometimes CI is controlled completely by the platform engineering team. So when developers upgrade something, they have to wait a week for platform engineers to upgrade Go on their Jenkins nodes. So it's not always easy, and it causes a lot of frustration between developers and platform engineers. And I'm sure there are other issues with CI/CD, but there are some lessons to be learned here. First of all, YAML is just a really, really terrible choice of language for software development workflows. I mean, we all use YAML for a lot of purposes. We use YAML on Kubernetes, or we use YAML for configuration. But we don't use, for some reason, we don't use a general purpose programming language for building our workflows. We use YAML for that as well. But it's not really reusable, like if you have like a long pipeline that you have to apply to separate projects, you just, most of the time you have to copy paste those pipelines between projects. And you don't have the same tools in YAML that you have in programming languages. Like if you want complex conditionals or loops, it's usually very hard to do in these YAML DSLs provided by CI systems. And YAML is not very portable, like not YAML itself, but the DSL provided by the CI systems. It's not portable. If you have to move to a new CI system, how do you do that? You have to rewrite the whole damn thing again, and you are back with push and pray, and you are wasting your time. So YAML is just a bad choice of language for software development workflows. But probably the more important lesson here is that developer and CI environments have more in common than differences they have. Like the constant drift between them is annoying, and probably the right solution would be to bring them closer together, like try to build something, some common ground between dev and CI environments that you can reuse. So there is no gap, there is no huge gap between developers and platform engineers. And this is what Dagger is trying to do. There are many other solutions out there, like there have been attempts, like build systems to try this. But Dagger is fairly new in the market. Who has heard about Dagger here before? And who has used it? Okay, not many. All right. So Dagger is basically this portable, programmable workflow engine, you could say, that you can use to build CI pipelines that run basically anywhere. So how does it do that? First of all, no more YAML. You can use your favorite programming language to build these complex workflows, software workflows that you have. Like, why wouldn't you use a programming language if you use a programming language for your business software? So you can use general purpose programming languages. I believe currently it's Go, TypeScript, and Python that are supported by Dagger, but the low-level API is GraphQL. So anything that supports GraphQL can basically work with Dagger. And you can use a programming language that developers and platform engineers already know. So it's not this YAML hell anymore that no one wants to touch. It's software. And the nice thing about this is that you can use the same tools that you use during your daily job to build your software. You can build reusable components that you can use across different projects. But probably the more important thing about Dagger is that you can build workflows that run anywhere. Dagger runs workflows in containers. So basically, you can run Dagger pipelines anywhere where you can run containers. But these days, you can do that on most developer machines. You can do that on most CI systems. So it's fair to say you can run these pipelines anywhere. And what that means is there is no more push and pray, right? You don't have to push to your VCS to try a change first, because you can run your CI pipeline locally. And that also means that there is no more drift between these environments, because they basically become the same. You run the same thing on your developer machine or the platform engineer's machine, then in CI. And by that, Dagger basically creates a bridge between developers and platform engineers, because they get to work on the same thing when it comes to building software. All right, let's see how that works. And let's see some code. So this is, I'm going to use Go as an example because I work with Go the most. But as I said, TypeScript and Python is also supported by Dagger itself. I also said that Dagger works with containers, so everything you do, you basically have to package everything to run in containers. And if you take a look at the API, like it's fairly similar to Dockerfile, right? So you have to create a new container, you need a base image, you need to set a work dir, mount some directories, and then run some commands. So it's fairly simple, and it's fairly similar to Dockerfile, which means it's probably easy to learn. And it looks very similar in other languages as well. Now, I also said that you can build reusable modules, and most of the time, you probably want to use some sort of a module for the most common tasks. For example, when you're working with Go, you probably want to use some Go module to do the basic stuff. And in this case, this is a simple Go module that I've built that allows you to run tests, build binaries. But there is actually a module repository called Daggerverse that you can go to, and you can find a lot of modules already up there. Daggerverse, I think it was released back in February, but there are already a bunch of modules up there. So basically, for the most common tasks that you may have, you can find a module up there. How do you run this? Dagger provides a binary that you can download and run your pipeline code, basically. It runs everything in containers, so the only other dependency you need is Docker on your machine, basically. And it runs the same way on the CI, so you don't need complicated CI workflows anymore. It doesn't replace your CI, it runs on top of your CI, but your CI pipelines basically become simple configuration to call into Dagger itself. Now, let's see some more code. And I have an example project here that you can check out if you want to. It's on GitHub, it's public. And I want to show you a couple of scenarios when introducing Dagger into an existing project, because I think that's the easiest way to understand how Dagger works and how you can apply it to your use case. So I have three examples here, and I think I should have time to go through each of them. So basically, I want to look at introducing Dagger to a project, and then I want to look at using modules instead of just the core Dagger API. And finally, I want to show you like a platform engineering specific use case, as the title says, without developers noticing a thing. So developers shouldn't notice that there's a new security scan in the chain. All right, let's take a look at some code. Is it large enough? Do you see it in the Mac? Okay, cool. So it's a very simple project. It doesn't do much. And we are actually, I'm just going to show you the code, very simple. It's just a HTTP server. It doesn't really matter what it does. But let's start with the developer interface. So let's say you have installed Go, you have Go on your machine, you have Go and CI lint on your machine, and you have a make file. That's the developer interface that developers interact with. And we're not going to change that. It's going to stay the same. Developers shouldn't really notice that something else is added here. So basically what we have here is a build command that builds the binary, a test command, a lint command that runs Golang CI lint, and we have like a CI step here that runs everything. So that's going to kind of mimic what we have in CI. So if I run this now, make CI, it should run everything, everything should succeed. Now let's see how this works with Dagger. Hopefully everything is going to run. You know the first rule of live demo is don't do them, but I'm going to try. So I've implemented all those three steps here in Dagger code, and it's very similar to what you saw before on the slides. It's basically a Go build step. It's a little bit long, but I'm going to get to that later. So it basically builds a binary, runs the tests, and I didn't even bother writing the Golang CI lint part because I'm going to use a module for that. It's just so long, I didn't want to put it in the example here. But basically, I have all three steps implemented here. So if I run something like make test, it's going to call into Dagger and run that test function. Hopefully it's going to work. But basically, developers shouldn't notice that there is something else happening in the background. It's the same interface for them. It's just running in Dagger. And then in CI, we can run the same stuff. And then we have like a CI job here as well that basically does the same thing. And this is going to be our primary entry point here and in GitHub Actions as well. Like we have the whole CI flow, and this is where you can see the real power of Dagger. You can implement the whole CI flow as a single Dagger call. You don't need to implement like parallelization in GitHub Actions or whatever CI system you use. You can implement the whole pipeline in a single Dagger function. So that's what happens here. I can also run make CI, and it's going to do the same thing as before. Again, developers may notice that some different stuff is happening, but the end result and the user experience is the same. And then I can go to, let's go to the PR. I can go to the PR itself. And I have the same thing implemented here. Let's go to the GitHub Actions YAML first. So instead of, setup go and running Golang CI-lint here, I have a single step that runs the same Dagger pipeline steps. And I have one for the whole CI pipeline here as well. So it's basically just a single Dagger call, and everything runs within Dagger. Now, let's go back to that huge example here. Now, chances are you have multiple projects in your company, right? Like most companies have multiple projects that they need to build. And you probably don't want to write a pipeline like this for every single one of them. You want to reuse some code. And you can do that with Dagger. You can build high-level modules. I already showed you Dagger where you can find some of those modules. So let's replace all this with something simpler. And as you can see, that whole build step just became a lot shorter because I have a Go module on Daggerverse that I can use. And it's actually a much nicer API as well. Like you don't have to think in terms of containers when you do a Go build. You can think about it as a Go build, like you would use the Go tool on your own machine. Instead of running things in containers. And it does the exact same thing that I had in my makefile before. Basically runs Go build, and it exports a file. Dagger has this nice abstraction, not just for containers, but for working with files and directories as well. So basically, as you can see, instead of just running Go build, I can call this build function, and it's going to return a binary for me that I can run on my machine. Once again, developers don't really notice that anything changed. That whole build function became a lot shorter by reusing a module. And everything works the same way on CI and on the developer machines. I should have a PR here as well, just to show you how things became simpler. Oh yeah, and now I have, so this is how you install modules. There is a Dagger JSON file that's Dagger's configuration basically. And you can either just list the dependencies here, or if you go to Daggerverse and look for Golang CI-lint, for example, then you can also use the Dagger install command to install these packages, so it's fairly easy. And now I have linting in my pipeline as well, because I can just reuse the Golang CI-lint module. Under the hood, I can actually show you how that looks like. It's much longer than. So under the hood, the pipeline actually downloads the Golang CI-lint binary, creates a new container for Go, copies the Golang CI-lint binary. So doing all of those steps in every single pipeline is just a waste of lines of codes. You want to reuse that. So you can use these reusable modules to do that. And then last but not least, let's see a real-world scenario where platform engineering teams need to introduce a new security scan tool into the pipeline. And normally, when you have like completely separate CI and developer environments, you can either ask the developers to install those as well and run security scans on their containers. They will probably refuse. I wouldn't want to do that either. So what you need here is a way to add new steps to the CI pipeline without developers even noticing. And if you introduce Dagger into your toolchain and build a CI pipeline like this, where everything is just in code and in there, and developers don't have to think about what tools are running in the CI pipeline, you can easily add new steps to that, right? Like developers don't have to know that there is something else happening in there. They probably don't care. They probably only care when something goes wrong. So let's take a look at that. And basically, it's also very simple because I just reused the 3V module from Daggerverse. And I just added a very simple security scan step that we can still run separately. Like this is a separate function I can call. Developers can call it if they want to. So if they think about it and they know they changed something in the Docker file, for example, they can call it if they want to. Or if they don't care at all, they can just call their usual CI flow. And if something goes wrong, it's going to tell them. So I can call that security scan function if I want to. And normally it just passes, hopefully. All right. Or I can just run make CI that runs the same CI pipeline and don't really care about what's happening in the background. Now, if I numb it up enough to go away, dumb enough to downgrade, for example, Alpine to something like, I don't know, 14.0, and I run make CI, it should break fairly quickly. Let's see. So it runs all the linter, the builds, and then it broke. Yeah. So the point is that it's much quicker to run these tests locally. It's much quicker than waiting for CI to pick up the changes. And you can do this all locally. And you can, from a platform engineering perspective, this is like automatic shifting left, right? Like you're putting that security scan into the same CI pipeline that you run on the CI, but the developers are forced to do that as well. All right. So that's all I had for you today. If you have any questions, I'm happy to answer them.
Yeah, now it's on. Hi, I'm Andrada from ING Hubs Romania. First of all, thank you very much for your presentation. A lot of very useful insights for some of us, for us. I have one question. You said that if we use this for our CI, but for the development environment as well, the main dependency might be Docker. Does Dagger work with other container runtime interfaces than Docker?
Well, technically, it works with any OCI-based environments. So it should work with Podman as well, I think so. But I think the primary environment they support and use is Docker. And some of the features, like service networking, so Dagger has a lot of features. Some of the features actually rely on Docker, but the core functionality should work technically with any OCI-based environment.
Okay, cool. And a second question, you said that you don't really have to implement parallelism in GitHub Actions. You can do that with Dagger as well, like have multiple stages, let's call them, run at once. Like I want to do the build and the security scan of the code at the same time. Something like this is possible to do with Dagger?
Absolutely. Like this pipeline I just showed you, that's what's happening. Go away. That's what's happening there. So basically here, I'm using Go routines in the background. Like this is a wrapper and Go routines, and it runs all of those steps in parallel.
Okay, cool. Thank you. Thanks again for the presentation.
Thank you. Any other questions?
Everybody's excited for lunch?
All right, so if you have any more questions or, I don't know, want to take a look at your use case or you're interested in more examples, feel free to track me down in the hallway. I'm happy to answer any more questions there. Thank you very much for your attention.